Let's proceed to laws of exponents for division. Remember, in dividing polynomials, the laws of exponents for division will be used. First law for division, that is the quotient of powers. That is in second law of exponents. Again, the second law of exponents is quotient of powers. When you say quotient of powers, for any non-zero real number a and for any integers m and n, this will be the condition. Okay, for number 1, a raised to m over a raised to n, and that is equal to, you will subtract their exponent, m minus n, if m is greater than n. For number 2, a raised to m over a raised to n. If m less than n, please take note, if m less than n, 1 over a n minus m. You will subtract their exponents. First, n minus m. For number 3, a raised to m over a raised to n. If m is equal to n, therefore, their exponent is 0. When you subtract their exponent, that will be the result is 0. Remember, if the exponent is 0, it is always equal to 1. Please take note of that. Again, if the exponent is 0, the answer is 1. Always 1. For the first condition, if am or m is greater than n. Okay, division examples, expression without exponent, quotient. 3 raised to 6 over 3 squared. So 3 raised to 6, if we use that expression without exponent, that is 3 times 3 times 3 times 3 times 3 times 3 times 3 over 3 squared is 3 times 3. Okay. So you will just simply use the cancellation method. You will cancel first 3 and cancel the second 3. And the remaining is, the numerator is 3 times 3 times 3 times 3. 4, 3. So it means that the exponent is 4. So 3 raised to 4. If we use this laws of exponent or this condition, m is greater than n. So it means that m, this is m, this is n. So you will subtract m minus n. So m here is greater than, so this will be the condition. You will subtract m to n. So m minus n. So 6 minus 2, that is 4. So 3 raised to 4. When you simplify, 3 raised to the exponent 4, and that is 81. Number 2, m raised to 6 over m raised to 4. When you express that without exponent, m raised to the exponent 6 is m times m times m times m times m times m over m raised to 4. There will be 4 m's. M times m times m times m. So that you will cancel out m. M from the numerator and m from the denominator. It has also the same numerator and denominator, m. Same as here. Also here. And the remaining is the 2 m's. There will be 2 m's, therefore it has the same base. It means that you will add the exponent. The exponent is 1 and 1. So there will be 1 plus 1 is 2. So the exponent is 2. That's why m squared. If we use this condition, m is greater than n. So m here is much bigger than our n. So 6 minus 4, that's why 2. And the answer is m raised to the exponent of 2. Let's go on to the second condition. If m is less than n, then this will be the formula or the formation. 1 over a raised to n minus m. Okay, example number 1. 5 squared over 5 raised to 5. So 5 squared, it can be expressed without exponent, 5 times 5. 5 raised to 5 is 5 times 5 times 5 times 5 times 5. Take note, remember they have the same numerator and denominator. It means that you can't cancel out if they have the same numerator and denominator. So 5, also 5. Numerator, you put 1. So 5 times 5 times 5. There will be 3 5. Therefore, your exponent is 3 here. And the base is 5. So 1 over 5 raised to 3. If we use this law of exponent, this condition m less than n. So our m here is 2 and our n is 5. So m less than n. So 1, if we use the formula, our a here is 5. And that will be our base. Our n here is 5. And our m is 2. That's why you simplify that. 1 over 5. 5 minus 2. That is 3. So 1 over 5 cubed. Or you simplify 5 cubed as 125. And the final answer is 1 over 5 cubed or 1 over 125. Example number 2. Y cubed over y7. M is less than n. Okay, so we will use this law of exponent. So if we express this one without exponent, that is y times y times y. If we express this one without exponent, that is y times y times y times y times y times y times y. So you will do the cancellation method. You can cancel out if they have the same numerator and denominator. Their variable are the same. So y here, cancel out. Another y, another y. No more numerator, you put what? So y, 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 y. There were 4 y's. So your exponent is 4. So y raised to 4. So the answer is 1 over y raised to the exponent of 4. Okay, if we use the formula for the law of exponent, 1 over our a here is y, which is our base. Our n is 7. Our m is 3. And that is equal to, you simplify that, 1 over y, 7 minus 3, and that is 4. So 1 over y raised to the exponent of 4. Okay. Let's proceed to condition number 3. If m is equal to n, therefore, it is equal to a raised to the exponent of 0 if our exponent is 0 and that is equal to what? Again, if the exponent is 0, the answer is always equal to 1. Please take note of that. Example, 2 raised to 4 over 2 raised to 4. So when we express this one, that is 2 times 2 times 2 times 2. Same as the denominator because they have the same numerator and denominator. So for this one, remember you can cancel out if they have the same numerator and denominator. So cancel out, cancel out, cancel out, cancel out. So no more numerator. All the numerators are cancelled out. Then you put 1. All the denominators are cancelled out. you put 1. 1 over 1 is equal to 1. If we use the law of exponent for this one, their m and n are equal or equal exponent. So 4 minus 4, and that is 0. So, or we use the formula a raised to 0. Our a here is the base 2, then 0. 2 raised to the exponent of 0, and that is equal to 1. Example number 2, x squared over x squared. When you express x squared, that will be x times x, same as denominator, because they have the same numerator and denominator. Both numerator and denominator, as you can see, are the same. It means that you can cancel out. So 1 over 1, and that is equal to 1. So if we use the law of exponent, as you can see, they are having same exponent, 2. So you will subtract 2 minus 2, and that is 0. So our a here is x, then 0, x raised to 0, and that is equal to 1. Let's proceed to the powers of quotients. That will be the fourth law of exponents. For any real numbers a and b with b not equal to 0, and for any integer n, quantity a over b raised to the exponent n. It means that you will substitute the exponent outside the parentheses. So you will substitute n to a and also to b. When you substitute, distribute n to a, distribute n to b. So that will be a raised to n over b raised to n. Example number 1. Quantity 2 raised to 4 over quantity, over 2 raised to 3 raised to the exponent of 2. Okay. So when we use the law of exponent, so you will substitute 2 to the and also to this one. Okay. Solution, 4 times 2. That is 2 raised to the 4 times 2. And also on our denominator, 3 times 2. The exponent is multiply. Okay. Then that's the time you distribute the exponent, which is the 2. Then simplify. 4 times 2, that is 8. 3 times 2, and that is 6. So the exponent is 2 raised to 8 over 2 raised to 6. Using the quotient of powers, m here is greater than n. So you will just subtract their exponent. So 8 minus 6. Okay, 8 minus 6, and that is 2 raised to the exponent of 2. Or when you simplify that, that is equal to 4. Example number 2. Quantity 3 squared over x, quantity raised to the exponent of 2. Solution. Distribute the exponents, which is 2. You distribute 2 to this one and also to x. Okay. So when you distribute, that is a multiplication. So 2 times 2, and also x has an exponent of 1. So 1 times 2. Then simplify. 2 times 2, and that is 3 to the exponent of 4 over x, 1 times 2, and that is 2. So 3 raised to the exponent of 4 over x raised to the exponent of 2. 3 raised to the exponent of 4 can be still simplified, and that is 81 over x raised to 2. Another law of exponent for division, and that is negative exponent law. Okay, what will be a negative exponent law? For any non-zero real number, a and any integers n, a raised to the exponent of negative n. Our exponent here is negative. That's why negative exponent. If our exponent is negative, this will be the formula or the form. 1 over a, which is our base, over raised to the exponent of n. Again, 1 over a raised to the exponent of n. Example, x raised to the negative 2. So, negative exponent. So, 1 over a over n, that will be the formula. 1 over x raised to 2. Okay. Another example, 3 raised to negative 2. Solution. If this will be our formula for the negative exponent, and that is equal to 1 over a raised to exponent of n, our a here, which is our base, which is 3, and n will be the number 2. That's why 3 squared. 1 over 3 squared, when you simplify that, that is 1 over 9. Then we proceed to the division of polynomials.
Are you ready for today's lesson? For today, we're going to discuss about dividing rational expressions. But before that one, we are going to recall the concept of dividing fractions. How to divide 2/3 divided by 1 over 6. From what we have learned before in our elementary days, dividing fraction has this process. You will copy the first term or the dividend 2/3, change the operation to multiplication, and get the reciprocal of the divisor. So the reciprocal of 1 over 6 is 6 over 1. Then you will now proceed to the process of cancellation or simplification. Can we simplify 3 and 6? Yes, because 3 divided by 3 is 1 and 6 divided by 3 is 2. Then multiply numerator times numerator. 2 times 2 is 4, and 1 times 1 is 1, or we could simply write this one as 4. Now you are ready to learn about dividing fractions. So before that, we're going to state here the different steps in dividing rational expressions. Number 1, copy the dividend. Second, change the operation to multiplication. Third, get the reciprocal of the divisor and simplify. So let's have example number 1. 3x to the 4th divided by 4 divided by 9x over 10. So from the given steps, we're going to copy the dividend 3x over 4 divided by 4. Change the operation to multiplication and get the reciprocal of 9x over 10. So the reciprocal of 9x over 10 is 10 over 9x. Now we're going to cancel out the things that we could cancel. So we could cancel 4 and 10 because we could simplify them. 4 and 10, they have a GCF of 2. So 4 divided by 2 is 2. 10 divided by 2 is 5. How about 3x to the 4th and 9? We could still cancel out 3 and 9 because they have a common term of 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. Now let's have x. X and x here. So there is 1x and there is x to the 4th. If we're going to cancel that out, there still remains x cubed. Now we could simplify further. What are the terms remaining on this expression? So 1 times 5, it's 5x cubed over 2 times 3, it is 6. So your final answer is 5x cubed over 6. Now let's proceed to the second example. 3x to the 6th divided by 5y to the 5th divided by 9x squared all over 25y to the 8th. So, we will follow the steps. Copy the dividend 3x to the 6th over 5y to the 5th. Change the operation to multiplication and get the reciprocal of the divisor. And the reciprocal of the divisor is 25y to the 8th divided by 9x squared. Now, analyze the given if there's something you could cancel. Yes, we have. Let's start here with 3 and 9. The common term between 3 and 9 is 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. And its variables, x to the 6 and x squared, we could simplify that as 1 and x to the 4th. How about 5 and 25? What is their GCF? Their GCF is 5, so we could say 5 divided by 5 is 1. 25 divided by 5 is 5. How about its variable? So y to the 5th and y to the 8th, we could cancel that out. And here, there's y cubed. So if we're going to simplify that one, it will become 5x to the 4th y cubed over 3. And that is now our final answer. How about example number 3? 4x minus 4y divided by x squared minus y squared divided by 8 all over x plus 1. If we could see the operations plus and minus class, that is your indication that you will do factoring. So what we're going to do first is we're going to identify what factoring technique are we going to apply in each term. Okay, let's start with the numerator here. Can we factor out 4x minus 4y? Yes, we can. So what kind of factoring can we apply on this? Yes, you are right. We're going to apply common monomial factor. How about on the denominator here? What factoring technique can we apply on this one? X squared minus y squared. Yes, you are right. We're going to apply difference of two squares. And here for x plus y, we cannot factor it anymore. It's already simplified. So now we're going to move on to the process. So copy 4x minus 4y over x squared minus y squared. Change the operation to multiplication and get the reciprocal x plus y over 8. What is the factor of 4x minus 4y? since we're going to use common monomial, you're going to identify first the GCF. Its GCF is 4. So separate 4. 4x divided by 4 is x. Copy minus. 4y divided by 4 is y. And how about x squared minus y squared? We have identified that we're going to use the difference of two squares formula. So we're going to prepare two sets of parentheses. Square root of x squared is x. And the operation each parenthesis is plus or minus or vice versa. Square root of y squared is y. And that's it. Copy, change the operation to multiplication. Just copy x plus y over 8. Now we're going to identify what are the things that we could cancel. We could cancel x plus y and x plus y here because they are the same. We could cancel also x minus y and x minus y. Then we could also cancel a 4 and 8 because we could still simplify them. What is the GCF of 4 and 8? Yes, their GCF is 4. So 4 divided by 4 is 1 and 8 divided by 4 is 2. Therefore, the answer is 1 over 2. And you need to box your final answer. Now, let's move on to the next example. Example number 4. X squared minus 3x all over x squared minus x minus 6 divided by x squared over x plus 2. So the very first thing that you're going to do, class, is you're going to identify what factoring technique are we going to use in each term, or if ever we could still factor them, or it's already simplified. Okay, let's have here first x squared minus 3x. What factoring technique are we going to use in this one? Yes, good. We could use common monomial factor. How about x squared minus x minus 6? Yes, we could factor this out using quadratic trinomial where a is equal to 1. And x squared and x plus 2 is already simplified, so we will not touch them anymore. So we're going to proceed now to the process of dividing rational expression. Copy the dividend x squared minus 3x over x squared minus x minus 6. Change the operation to multiplication and get the reciprocal of the divisor. So the reciprocal of that one is x plus 2 over x squared. Now, start factoring. So in the numerator, we've said that we could factor this out using common monomial factor. So their common factor is x. And x squared divided by x is x minus 3x divided by x is 3. And we're going to proceed now to the denominator. Prepare two sets of parentheses. Square root of x squared is x. And you already know how to factor out quadratic trinomial where a equals to 1. The operations of each parenthesis, it will be minus and plus. Then you're going to think of factors of 6. That if we're going to minus, the answer is 1 because there's an imaginary 1 here. So I think it would be 3 and 2. Then proceed to the next one, x plus 2 divided by x squared. Now you're going to think of something that you're going to cancel. Here, we could cancel x plus 2 and x plus 2, x minus 3 and x minus 3, up and down. Here we could still cancel x squared and x because they have common. They have something common. They have x as their common term. So x divided by x is 1 and x squared divided by x is x. Therefore, the simplified form of this one is 1 over x. And we will box our final answer. Now let's proceed to example number 5. X squared plus x minus 12 divided by 2x plus 6 divided by 4x plus 16 all over 6x plus 18. So again, we're going to identify first what factoring technique are we going to apply in each expression. So let's have first x squared plus x minus 12. What factoring technique are we going to apply on this one? Yes, we could use quadratic trinomial where a is equal to 1. How about this one? What kind of factoring technique? Yes, we could apply common monomial factor. And same thing for 4x plus 16 and 6x plus 18. We could have them together for common monomial factor still. So we could now proceed to the process. Copy x squared plus x minus 12 all over 2x plus 6, change the operation to multiplication, and get the reciprocal of the divisor, which is 6x plus 18 all over 4x plus 16. Then factor now. So if we're going to factor, since this is quadratic trinomial where a equals to 1, we're going to prepare two sets of parentheses. Square root of x squared is x, copy plus, and since it's minus here, meaning the two parentheses don't have the same sign, so it's minus. Think of factors of 12. If you're going to minus, the answer is 1. Yes, you're good. The answer is 4 and 3. Now let's proceed to the denominator. We could factor this out using common monomial factor. So what is their common term? Their common term is 2. Separate 2. 2x divided by 2 is x. Copy plus. 6 divided by 2 is 3. Multiplication, and we've said that this 2, the numerator and the denominator of the divisor, we could still factor it out using common monomial factors. So their common is 6. 6 plus 18 divided by 6, that's 3. And in the denominator, their common is 4. So 4x divided by 4 is x. Copy plus. 16 divided by 4 is 4. Now we should look at what are the things that we could cancel out. So we could cancel here x plus 3 and x plus 3 here, x plus 4 here, and x plus 4 on the other side. How about the numbers? Let's start first with 6 and 4. Their common term is 2. So 6 divided by 2 is 3. 4 divided by 2 is 2. I think there's nothing that we could cancel, so we could now simplify. So the remaining term here is 3 and x minus 3. Then over 2 times 2 here, so it will become 4. Then we want class to simplify further, distribute 3 to the terms inside the parentheses, so it will become 3x minus 9 over 4. Then box your final answer. Okay, that's all for now for dividing rational expressions, and you are ready to answer the summative assessment. Thank you and God bless.